Okay, so I hope I can continue on here. But this is part 2. So I know what I need to do here is I've got to say, I know that 3x minus 1 equals y plus 2, right? The problem is I don't know, I don't have one of these expressions with one variable in it. We also know over here that we have x plus 3 equal to y. Well, do you remember back in algebra, I realize that was quite a while ago, back in algebra when you had to isolate a variable and then you could plug in for that variable. So right here, look at this. This tells me that y equals x plus 3. Well, up here, I have a y. Can I substitute this? Does this equal y? Yeah, it does. So if you have something like that, you can plug it in here. And even if you don't, you can manipulate it around and then solve for that. So over here, I'm going to rewrite this expression, and I'm going to plug this x plus 3 in for that y. So that would be 3x minus 1 equals x plus 3 plus 2. Well, this is x plus 5, and this is 3x minus 1. I'm going to subtract my x, getting 2x, and I'm going to add 1. Now I'm going to divide both sides by 2, and I know that x equals 3. So up here, I can go back and look at this expression again and substitute my x value in that I found here. So I'm going to put a 3 in place. So I know that 3 plus 3 equals 6. So when I do that, I know 6 equals y. That's what we're going to do. We know that 6 equals y and 3 equals x. And those are my two solutions. You have a similar problem over here in number 5. Please really think about what we did and try and do number 5 on your own. Look at number 7 here. Number 7 is very similar to number 2 that we did, so I don't really feel the need to do it again, but I'm going to come over here and look at number 8. In number 8, we know all 4 angles with x variables. There are a couple of different ways you could do this problem. You might think automatically, oh, it's a quadrilateral. I know all of those angles add up to 360 degrees. Or maybe you know that opposite angles are congruent. So you pick a pair of opposite angles and you make them congruent to each other. Or maybe you think that you have consecutive angles, and you know that consecutive angles are supplementary. So you would say this plus this would equal 180. All of those choices would be correct. However, I'm just going to do the opposite angles are congruent and then solve for x. So 3x, and I'm going to use this one and this one, minus 15 is going to equal 2x plus 25. I'm going to subtract 2x on both sides and add 15 on both sides. Now I'm kind of doing this all in one step. I hope you guys can follow it. Normally we would go row by row, but I don't want to run out of room here. When I subtract, I have an x here. That's gone, and 25 plus 15 is 40. So I know that x is 40. If you wanted to know each of the angles, you could go in and you could plug 40 in for each of these x variables and find all of the different angles. So looking at number 9, number 9 is very similar to number 1. Number 10 is similar to number 2. 11 is very similar to number 3. And 12 is a trickier one. It's not really tricky, but it's the first one we've had like this. Now, they're telling me that this segment is 4x minus 1, and this segment is 3x plus 4. I know that these two segments, because this is a parallelogram, I know that they have been bisected, so I know they're going to be congruent. So we would say 4x minus 1 equals 3x plus 4. Subtract 3x on both sides. X, add 1 to both sides. We know x is 5. And that will be your answer there. Now I do want you to take a shot at 13 and 14. And in 15, I want you to make sure you draw a picture. And we're just drawing a parallelogram. I know one angle is 47 degrees. Can you find the rest? Well, you can, but I want you to think, how would I do that? Look at your pictures on your tab and see what would you actually do. Now let's jump over to 6-4. And we're looking at now, we have to decide, is this a parallelogram? Is the parallelogram a rhombus, a rectangle, or a square? So you're going to be looking in your flip book at the rectangle tab, the rhombus tab, or the square tab. And you're going to be deciding, does this have those characteristics? So looking at this first one, number 1, I want you to look and see, what do we know about that shape? I know it has 2 pairs of congruent sides. Notice all the sides are not congruent. And hopefully right there that tells you what kind of a shape it is. But this in the corner should clarify for you. Because if it didn't have the right angle, it would be a parallelogram. But it does have that right angle. So which shape is it? Here's number 2. The really important thing here on number 2 and number 3 is, do you know the corner angles? Did they tell you it's a right angle? Think about that as you do those two. And then look at number 4. What do you know about the sides? What do you know about the angles? Make a decision as to whether or not it's a rhombus, a rectangle, or a square. And now let's go to the back. And on the back, I'm trying to go up here to this. Which quadrilaterals have this property, that opposite angles are supplementary? Now remember, where do you see that in your flip book? Is it on the quadrilateral page? I'm going to zoom out here for you. Is it on the quadrilateral where we hear about that opposite angles being supplementary? No. How about on this page? Do we have it on there, opposite angles are supplementary? Well, it's right there. So how do I know which shapes have that as a characteristic? And do you remember why we did this flip book? I shared with you that anything that will lift this page has that property. So when I lift up my quadrilateral page, does it move the parallelogram? No. So a quadrilateral does not have the properties of a parallelogram. But what about a rectangle? Does a rectangle have the properties of a parallelogram? Yeah, it lifted that yellow tab of mine, so it has those properties. So right now I know a parallelogram and a rectangle have those properties. But what about a rhombus? Does a rhombus have that property? Yes. What about a square? Does a square have that property? Yes. So in the case of these opposite angles being supplementary, we would list all 4 of these. Now I know you guys are all about shortcuts, so if you want to make a shortcut for writing the word rhombus, you can abbreviate it RH, and rectangle can be RC. Okay? So opposite angles, we decided that a parallelogram has that property, a rhombus had that property, it lifted the tab too, a rectangle had that property, and a square had that property. Try these other three on your own and think about what we just did with lifting the tabs. If you can lift, if when I go and I'm looking at my property, if there's anything below it that will lift it up, then it applies to that. And I hope you guys can think about that, because that was really the big purpose of this whole flip book, is to allow you to think about that. Now let's look at number 9 down here. It wants us to decide the measures of all of these angles. It tells me this one is, that I know this angle right here is 35. Well, let's go to our rhombus tab. And let's find, and I'm trying to make it so all you'll see is that rhombus tab, so that we can just focus on that. What do we know happens with our diagonals and the rhombus? Well, looking at my picture, I can make those exact same marks on this picture. I know every single one of those is 35 degrees. So I can put 35 degrees in each of those. So what is angle 1? Okay. Now they did tell me this is a rhombus, and I'm on that tab. What do we know about, do you see this triangle right here? And I'm sorry I don't have any other colored pens with me right now. I know one angle in that triangle that angle 2 is in, and that's the angle they want me to tell them. Do I know anything about this angle right here? Well, we do. We know that the diagonals form right angles and are perpendicular. Well, that means that this is a right angle. So if I know one angle in that right triangle, can I find this other one? Yes, we can. We know that all three of those angles sum to 180 degrees. So I know 90 plus 35 plus angle 2 is going to equal 180 degrees. And then we would solve that. So I really want you to look at your flip book. I want you to think about what you know in on those diagrams and add it to the diagrams. I'm not going to solve this for you. I want you to do that on your own, because I feel very comfortable that you guys can do those types of problems. I mean, I'm going to put my degree marks in though, so I don't forget I'm talking about angles. Now let's look down here at number 11. This is a rectangle. Automatically, I want to go to my rectangle tab. What do I know about rectangles? I could go and I could put all of these marks on my picture. Matter of fact, I'm going to. This is a right angle, this is a right angle, this is a right angle, and this is a right angle. I'm going to put my diagonal marks on there. I know all those diagonals are congruent. If you really want to practice this, you could then go to your parallelogram tab and put all of those markings on as well. I'm not going to require you to do that, but I think that helps you think about the problem. Well, now let's look at what they want us to know. They want us to tell them what the measure of angle 1 is, the measure of angle 2, measure of angle 3, and the measure of angle 4. Well, angle 1, if this much of this 90 degree is 30, what does it mean that has